were you doing beyond just solving? You were. Okay, so let's do this. Let's say we have 3b plus 9. And that's equal to 33. So what's the first step? Subtract 9. Or add negative 9. We add the opposite of it. That's not where I was going. So if you wanted to, you could say, well, I'm going to add the opposite of that. And that's okay. And sometimes for some people that helps. I mean, that's easier to look at. Sometimes it's easier to look at because then what they're doing, let me see what I see. Okay, yeah, so then what they're doing is when they have another problem like 140y, subtract 800 is equal to 600. And they look at that and they say, well, what do I do? And right away, a lot of you will have an inclination to subtract 800 because you're just kind of zeroed in on that. But if you subtracted 800, then this side would be 140y minus 1600, and that's not where we want to go. So if you added the opposite of what's going on there, and if in here, why is that okay? Because subtracting 800, this is important, is the same as adding a negative. It's important to see subtraction as adding a negative, you guys. It'll make things much smoother for the next couple of years. And in this case here, now you have a negative 800 and you're adding the opposite of it. So it's a different way of looking at it, TJ. But I want you to look at things differently, Isla. I want you to see things differently than what you've seen them before. And realize there's more than one way to look at it. Solving. Because, believe you me, over the next couple of years of your math, we're going to turn your world upside down with new ways to look at things. And that's what you need. You need to have that. If we're going to solve the big problems of this world, and you are the ones that are going to do it, you need to learn to see things not the way you saw them yesterday. See them differently. So, in this case here, we got 3b is equal to, what's that, 24? Yeah. And then what do we do? Divide by 3 or multiply by the reciprocal, either one. I'm going to do it that way just because. And then a third of 24 is 8. Okay. So now we're to where I was talking at the beginning. What can be done from here?
You could check it.
Check it, yeah. And that's what I didn't emphasize yesterday, and I want you to do today. Because when I was walking back and forth out there, I was like, oh, I didn't get anything like that. Oh, I got this for an answer. I got that for an answer. Well, somebody's got to be okay, and somebody's got to be not so okay with their final answer. And how do you find out? Well, you check. So you take that 8 and you put it back up into, into there. And you say to yourself, is 3 times 8 plus 9, is it equal to 33?
Yes.
Yeah, and you can either do it in your head or you can write it out. It's up to you. With that problem right there, I expect you'll do that in your head. You say, oh, yeah, 24, 9, 33. Yep, done. And then you know you have the correct answer. But if you, let's see, what do we have? Did I give you number 12 to do?
Yeah.
Okay. Did I give you number 13?
Yes. Yes.
How about number 18?
Yeah.
Oh. Which one should we look at and check together?
18.
12.
Okay. Well, with 12, the first thing you need to do is combine like terms and have a common denominator. How open-minded are we today?
Very open.
Yeah. There's a whole lot easier way to do number 12 than what
Just make
any
it
of you
one.
probably have done.
Just make it 1.
Just make it 1?
Well, like you can add 1/3. Wait, no, I messed up. That's my bad. I
Right.
did something stupid.
You're a relatively sharp crowd, and I think that you might be up to this one. You don't have to be, but let me show you something. How many of you like fractions, think they're a lot of fun, you want to do more of them today? Okay, so I got one taker for that. Clover.
Man.
There's nothing wrong with that. We live in a fraction world, people. Nobody's ever split a pizza into 0.3 repetins when there were 3 of you staring at
That
it.
is a third.
Right.
So you cut the, or you just eat the whole thing.
Okay, so
Yeah, exactly.
You don't even cut it, you just eat it like a big old.
So if you look at this and you get a common denominator out of it, what is the common denominator?
Well,
What?
I would say it was 20. I mean, not 20.
I would say, wait, 12 out of all of them?
Well, yeah, you have to do it, you have to get all of your fractions put away. You have to have them all put together with the same denominator so you can add them.
You can do quarter first
And
and
then
then
you just,
take away the.
and then you just multiply whatever you
Oh.
get by its reciprocal.
Okay, so you can just do those so you can then multiply by the reciprocal.
Yeah, then you can.
Oh, I see, I got you, okay. Yeah, because then when you multiply, you don't have to have the same denominator. So really, you just, yeah, 12, okay. What if you got the common denominator of all of them?
No, not 15.
Yeah, it would be
60?
Yeah.
Yeah, because it has to be 12, for sure.
Yeah.
But 12 doesn't work, so now you gotta go by 12s until you get something that 5 goes into. And 5 doesn't go into 24, 36, 48, but 60. Okay, so. When I do this, what I'm saying is I'm gonna multiply everything in the parentheses by 60. Which you may think, that's a lot of work. But watch. This is the distributive property, except you're doing it on both sides of the equal sign. So I'm not gonna multiply them, I'm just gonna write out what I'm multiplying. 60 times a third plus 60 times 2/5 x plus 60 times 3/4 is equal to 60 times 2 to the 12th. It looks really complicated, but I've been stressing to you to simplify before you multiply. So this 60 divided by 3 equals
20.
So 60 divided by 5 before you multiply it by 2. 60 divided by 5 is 12 times 2 is,
24.
now 60 divided by 4.
15.
15 times 3 is, we haven't reached for a calculator yet, have we? 60 times 2,
120.
but let's do this first. What's 60 divided by 12? Okay, so we're going to add 5 to 60 times 2. Okay, guess what? You have no fractions left anymore, do you? It makes life a lot easier when we don't have fractions.
Okay, well, then.
And this is exactly the same as the original equation. It's just everything's 60 times bigger.
Would you just divide the answer by 60? What if you get that?
No, you don't have to,
You add everything.
because we made both sides of the equal sign 60 times bigger. So everything is equal. It's the same equation. It's just written without fractions. And you can put this one in your graphing calculator, you can put that in your graphing calculator, and they will come out to be the same, exactly the same. Yeah, clear the denominators.
Well, what is x then?
Well, I don't know, we have to find it. So now you have 20 and 45. What's 20 and 45?
65.
And now we are going to subtract 65. So then 24x is how much? 60. Then we have to, no, not subtract, that's multiplication. Divide by 24. Divide by 24. So now what's x? No decimals. No decimals. Decimals will make it very difficult to check this. How about if you just make it a simple fraction? Don't worry about it being a mixed number. Simplify the fraction.
5/2.
Is it 5/2? Because 12 goes into there 5 times and 2 times. So that's just 2.5. 5 halves. But if you leave it as 5 halves, you can check your answer very, very easily. So now we're going to use what's in the parentheses, and we're going to ask ourselves, if we put x is equal to 5 halves, is this true? So this one we might not do in our head. But let's do this multiplication first. What does this equal? 1. So a third plus 1 plus 3/4. So we just have to come up with a common denominator, probably 12, right? So 1/3 is how many 12ths? Okay. And 3/4 is how many 12ths? Multiply by 3, multiply by 3? 9. Okay, so now we have 1, and then we have 9/12, and 4/12 makes how many 12ths? So here we have 1 plus 4/12 plus 9/12. That's 13/12, which is 13/12 as a mixed number is 1 and 1/12. 1 and 1/12 plus 2 is 2 and 12. So it worked. That's one way. You might not like that. You might just want to put them all into, do what you have to. So, your 1/3, you would change that to 4/12. And then you have 2/5 x. And then your 3/4 is 9/12. And that's got to equal 2 and a 12. And you might want to solve that equation. And that's okay too. Nothing wrong with it. 4/12 plus 9/12 is 13/12. And I thoroughly believe in leaving things as simple fractions, not as changing them to mixed numbers all the time. So now we have to subtract that. So you have 2 and a 12 subtract 13/12. And we saw it before that 13/12 is 1 and 1/12. So this just ends up being 1. Now we multiply by the reciprocal. And x is equal to 1 times 5/2, which is 5/2, which is what we got over here. So you can do this any way you wish. Yeah. Leave the calculator alone with this stuff. Try your best to push yourself on getting familiar with finding common denominators, doing the basic multiplication and division in your head as much as you can. Force yourself to do that. Because the further we go into math, the more we need to do that to make the problems work. And just do your best to try. Try to get better with your mental math. And stop me and bug me when I start going really fast. If you don't ask me questions, I'll just go faster and faster. Yes,
Can you explain number 19?
we can explain 19, sure.
We're supposed to do 19?
Going back
Oh,
to like number 16 here, did I give you 16 as an assigned problem?
no.
No? Well, if you looked at 16 though, what's different about that one? There are parentheses. So being that there's parentheses, they have to go away, don't they? What's that? What did you say? You don't add 2 first. No. You have to remove the parentheses to get M out, maybe.
Then I
Mr. David,
Yeah?
wouldn't it be 14 minus 7M?
yeah, 'cause
It'd be 14 minus 7M, yes, if you remove the parentheses, because you have to distribute the 7. Yeah, so you have to take the 7 times the 2, and then subtract the 7 times the M, you bet. But you could also add 11 to both sides first. This is an interesting problem. You should write it out. I see you have a pencil in your hand. This is good. This is an interesting problem because a lot of people want to, and, even in my higher level classes, they want to go and remove the parentheses and everything. And you don't have to all the time. Sometimes you can get away with something else. Let me write it on the board here. If we were to just to add 11, that's okay, because we're not doing anything inside the parentheses. We're not violating order of operations. What do you get with -4 added to +11? How much? +7. So look at that.
Oh, is M just 1?
Mm-hmm.
I don't get how M would be 1.
So,
So then seven times
minus-
away is
Rylan,
seven.
Rylan, explain yourself, and there might be more than one way of looking at it. Explain what your thinking is.
2 minus 1 equals 1, and then 7 times 1 is 7. And then, I can't explain well.
I don't know, how would you explain it?
Well, since the answer's 7, you're doing 7 times, but in the parentheses, you know that it has to be 1, because otherwise it can't be 7.
So she says the answer is 7, so it's gotta be 7 times whatever's in the parentheses to make 7. So that has to be 1. So both of those are good ways of explaining it. Let's look at it this way. This is 7 multiplied by that number. And we can divide by 7. We can divide by 7. Without even doing the distributive property, because this is like a separate number. And then we have 2 minus m is equal to 1. And then 2 minus m is equal, well, m's got to be 1.
Yeah.
2 subtract 1 is 1.
I'm not good at it.
No, but that doesn't mean that we're not going to talk about it.
But then if you follow it through with doing like the actual, like about doing the thing that we've been doing, when you add 2 to get rid of the 2, and then like add 2 to 1, and then you would say that m is 3.
Okay, so here's where it's nice to say that that's plus a negative m. This is a positive 2. So how can we remove this?
Subtracting 2.
Focus up here. Daydream off. So by subtracting 2, we're just going to go through, you'll hear me say it again. Set it up right, and then trust the algebra. Trust the steps that you know are true. If I say I subtract 2 and I subtract 2, they're still equal. You know, trust it and see what it looks like. So that goes away. Now you're left with negative m. 1 subtract 2 equals negative 1. Okay, now the opposite of m is the opposite of 1. So if the opposite of m is the opposite of 1, then m's got to be 1. Yeah, so m is equal to positive 1. And you can prove this by multiplying both sides by negative 1. If you multiply both sides by the same number, they're still equal. Negative times a negative is a positive. Negative times a negative is a positive. Looks different, doesn't it? Every one of these little things you have done over the last couple of years, multiplied by negative 1, divided numbers. You've done all of these little things, but now we just got to start piling them all together to solve bigger problems. And it becomes a little mind-boggling to keep it all in order. But that's one of the reasons I say I want you to write everything down line by line. Because you look all the way to the beginning of this, and you pick it apart one piece at a time. Took one piece out of it. And then we wrote everything. Then we look at this, and then we tear it apart one piece at a time. And we don't do the whole thing once. And that's why I say we don't want to be trying to solve this stuff in our head. Because like number 18, do that in your head. I don't know. That's a challenge. I don't want to do that. I'll scribble something out no matter what. But somebody said with this problem here, with number 16, to try to remove the parentheses first. So let's see what that does. So that's 14 subtract 7m, subtract 11 is negative 4. So we write it all down and then we ignore this. And then we just look at that line. What can we do to this to slowly get towards, you could add 11. Write down what's left over. That 0 canceled. So there's your 7, right?
Yes.
Now what? If I add 14, then I'll have 28. Subtract it. Because 14 subtract 14 is 0 cancel. It's gone. Don't forget about the negative. 7 subtract 14 equals negative 7. You see it? Divide by. If you divide by 7, this will be negative. But if you divide by a negative, it turns to a positive. So if I divide by a negative divided by a negative is a positive, and it's 1. We don't have to check this because we did this before. Yeah, Clover.
Did I say 16 or 19?
I don't know. I think you said 19, and I looked at 16. It's on the list of stuff to do. That's a harder one. Involves a lot more steps. I don't expect you all to walk out of here and say, oh yeah, okay, I got that. No problem. But I want you to see it. And then the ones that I assigned you, those we should be able to do most of those. So here's your task with your homework. I'll talk about 19, sure. But your task with your homework is to go back to every single problem and check them if you haven't already. Take your answer, substitute it in, and see if it's the correct answer. If it's not the correct answer, you've got to go back and figure out what the problem was. The problem with your answer. So for example, this one here, I would take 1 and I would put it back up here and I'd say, well, 7 times 2 minus 1, subtract 11 equals negative 4. Either do it in your head, or okay, that's 7 times 1, so that's 7 minus 11. Oh yeah, okay, I can get that far and see it's the correct answer. And if you have the wrong answer, go back and find where your error is. The most common errors deal with negatives. So things like adding when you should have subtracted, or when you divide by a negative, getting a positive, or not dividing by a negative when you needed to divide by a negative. Those are your most common errors. I'd say like 95% of the time, it's negatives. Because you think back, that's the stuff you got to stop and think about when you're doing multiplication, division, negatives and stuff like that. And they are there forevermore. The younger you are, the easier it is to learn. Next year, you're going to be older, so keep trying to learn this year.
Wait, so our homework is to go back and check?
Yeah, go back and check everything.
And we can do that in our head.
Well, I want you to write something to show that you've done it. Some of these you can go back and check in your head, yes.
Can we just write the check mark?
Yeah, but some of them you can't. And I know which ones you can and can't do in your head. You start throwing fractions in there, we're not doing those in our head. You better write something. And then you will see why leaving your answers as simple fractions rather than mixed numbers makes it easier to check your work. So Tom has a 490-page book to read. If he has already read 56 pages, how many more should he read each week to finish in 6 weeks? So the key is writing an equation that represents or uses the numbers that are in this word problem. And getting that math equation to use symbols so that it reads the same as the word problem. Yes?
Can you explain how to get that equation? Because I tried like 3 different equations.
Yeah, I can. I'll try that. There are a bunch of hands up in the air. What else do you have for, did you have more questions leading into this, or?
I mean, I could solve it, but I couldn't get like an AX plus B equals C.
Yeah. Yeah, so if we were gonna write something like this, where what's underlined are variable, are gonna be actual numbers when we're done. And then one of those, I think, is gonna be a variable when we write the equation, and 2 of these we know, but which 2, I don't know. If I think of distance is equal to rate multiplied by time, rate is gonna be units per units. It's gonna be like miles per hour, pages per week, weeks per page, whatever. So when we look at our units, both of them are gonna get used here. And that's gonna be this part of the equation. So this is the ending amount. And the B, remember when I showed you graphs? And we talked about this point here on the y-axis. I said that was when x is equal to 0, so we interpret that as the beginning amount. So he's got a 490-page book to read. He's already read 56. So you've got 490 pages. You've got 56 pages. And then you have how many more pages should he read each week? So that's pages per week. And it's a number that we don't know. So that's a variable in 6 weeks. So I like to look at these kinds of problems as, where are we starting? Where is he starting? Is he starting on page 1?
No, 56.
He's on page 56. Okay. And then I also like to look at the answer. What is the question asking? And then when you answer it, what will you be saying?
Yeah, it's like pages per week.
It's gonna be the number of pages per week? Really? Okay, so that's gonna be a variable. So it's either gonna be here or it's gonna be here, one or the other. Because we've got this taken care of. That's the starting point. But this has to be a rate. And what rate do we have in the things that we wrote down?
6 weeks and pages in the variable.
Pages per week is going to be a variable. So I think that that's going to be here. It's going to be in here. So we might have like, let's use the variable x, pages per week. What's this 56? That's pages. Okay. And then, when we're all done with this, when he's all done reading, how far will he have gone in the book? 490. So if you take what he started with, what he's got to read, and you put it together, you get where he ends up. So what goes right here? 6 weeks. And then you see how the weeks cancel, and now all the other pages. So there it is. So if we wrote this x times 6 plus 56 is 490. Or you could write it 6x plus 56 is 490. Now you can solve it, and then you can see if it makes sense. Hard. They're hard to write. So when you get into this, underline the important pieces, or circle them, or write them off to the side like I did here. And then think in terms of something of this nature. A rate times something plus a number is equal to the end amount. And I think a lot of us, we want to take these two numbers, put them together, and make it equal this, and that's harder to do. Phoenix?
Wait, so what would the answer be?
I don't know. That's not the hard part.
I feel like the answer is much harder than just doing the total pages, subtract the amount that he's read, and then taking that number and dividing it by 6.
Yeah.
Yeah, that's what.
It's the same exact thing.
I know, but it's so much
It's the same equation rearranged.
Yeah, and it makes more sense for the.
And what does this equal?
72. Oh, the top
72,
number.
70.
Equals x, right? Okay, so let's see, 490 pages, subtract 56 pages, divided by 6 weeks is equal to x pages per what? 6 weeks? No,
Per 1 week.
for 1 week. Okay. So, let's see here, if I subtract 56, well, look at this. 490 minus 56, I'm not gonna subtract yet. Divide by 6, right? Oh, looky there. Isn't that the same equation?
Yeah.
490 minus 56 divided by 6. Same. And that's good that you see it that way. What's really cool about this way is that when we spend more time with graphing equations like that, when it's written like this right here, you can just simply graph it by looking at the equation and not having to do any real arithmetic. And that's where we're going to something different. So you're like on the Wizard of Oz. You can go this way and go that way. How many does she have to choose from? 3 roads? But she just follows the yellow brick road, right? But she doesn't know where she's going. So that's what we're kind of like living right now.
Yeah, there's only.
There's only left and right?
Yeah.
Oh, okay, so there's only 2. So you can go this way, you can go this way. This way, by learning to write them as such, will help you with graphing. Graphing without having to do a whole lot of arithmetic, because this number right here is 56, and this goes up 6 whenever you go over 1. And when you get to this end point up here, that ends up being 490 pages. That'll become more evident as we go. So you know what you need to do. You need to go back to this, the top portion of this thing. You need to check all of that. That's your homework. And between now and when you start that work, you need to show me what you can do with this. Why are there so, it feels like there's so few of these. Did you guys walk in and grab stuff off of here?
No.
You want me to make copies for you while you?
I'll just run them off.
He is safe.
You can use your notes, you can use your homework. The ones that are crossed out, you're not doing. Well, they usually don't want them, I just did it because I had the time. So I would just give it to them, thanks.